This conference will now be recorded.
Can you all see my screen?
Yeah, it's visible.
Okay, good. All right, so let's start with the our next topic. But yeah, let's discuss what we discussed last time before we ended our session. We were discussing replenishment, and in replenishment, I explained you how the task, what is the purpose of replenishment, and how the tasks are created in replenishment through a program SCWM slash REPL. And basically, we try to understand with the help of a supermarket example how you can replenish your fixed bins all the time, the different types of replenishment, planned replenishment, order based, crate part, and automatic replenishment. Okay, so we are in process of discussing our internal warehouse process. We discuss ad hoc movements, we discuss posting changes, and we also discuss replenishment. So today we will start with physical inventory. Okay. So any questions before we jump on to our next topic? Okay. If no questions, then let me open. Okay. So what do we do in physical inventory process? What are the steps in a physical inventory process? So physical inventory process, basically, we count the bins. We have been doing that in MM as well. So in physical inventory process, we create a physical inventory document, count it, and then we post in system if there are any difference. Okay. So differences can be plus or minus. If it's gain, it's a plus, and if it's a loss, it's a minus. So 711 and 712 movements are posted in system. So in system, you will see process like this. First, a PI document is created. Okay, the document remains in inactive status. We activate it, and then we um, we activate the document. Okay, we create a document and we activate it, and then once it is active, system creates a warehouse order that can be printed. Printing step is optional. Since we are using RF, we don't need to print a physical inventory document. We can basically count it on the scanner directly. Okay, then we count the PA document, and finally we post the document. Okay, so basically, if we at any point of this process, if we feel that we for some reason we don't want the document, so we can delete it. Okay, for some reason you feel you don't want to do this physical inventory today, you can delete it at any point of time. If, for example, you have posted a recount of your physical inventory, sorry, posted the count of your physical inventory, and if at all you see the difference is too high, so you can post a recount. Okay, or initiate a recount process. What is a recount? You counted everything and then you want it to be counted again. Ideally, we would want it to be counted by another user, okay, to make sure that the counts are correct. I mean, the count entered was correct. So, for example, if the bin had one piece, but when somebody counted it, it showed 1,000 pieces. There's a big difference in terms of value or quantity. If you can also maintain tolerances, like if the tolerance is exceeded, if the difference is more than 10%, it can automatically go into a recount as well. Okay, so we'll see this process, and in this process, once the PA document is posted, so So basically, we create a document for a bin, PA document for a bin. We correct the stock in a bin, but that will not immediately go and update ERP. Okay, so we can we can continue to do the posting, and then for updating ERP, we use a transaction called as difference analyzer. Okay, so all your physical inventory postings, they are accumulated here. Like if you found something plus, if you found something negative for a particular product, everything gets accumulated here, and through the post here you make a cumulative posting to ERP. Okay, so through this post you can make a cumulative posting to ERP. So whatever will be a net difference, it will be posted in ERP. Minus plus all will be combined, and then you will update ERP. So the benefit of this transaction is that you can group together your differences for multiple physical inventory document. So you know, ideally, if you have found one piece extra in a bin, you would, if you post it, it updates, a material document is created, updates ERP, and a material document is created. If you found one piece less somewhere else, minus one, another PI document is posted in ERP. But if you have difference analyzer, the net difference is plus minus, it nullifies and it doesn't update ERP. See, in warehouse management, most of the differences, you know, are nullified because the material may be in bin A, but in the as per system it is in bin B. So when you do that posting, you say, hey, the handling unit, there's no handling unit here, but then you say, oh, hey, the handling unit is in A, and then you nullify that. So when you nullify that, the update in ERP is zero. Okay, so the difference analyzer is again very important tool, and then I would like to explain you another point before going into configuration, the tolerance bit. So there are three tolerances in the physical inventory process. One, the tolerance is assigned for the difference analyzer posting that we just discussed. So users are assigned to tolerance levels. So if the user has if assigned to HOGH, these are in German, which means high, medium, low. So if it is having a high tolerance limit, so you can post differences up to 10,000 euros. If it has low, then you can post up to 100 euros. So basically, you have authorization as per the levels of the amount, and also you can, if you want somebody like the general manager of the plant, you can just say no tolerance. If you want him to post unlimited, then give him 99999 or say no tolerance. Okay, so this is the tolerance level for the difference analyzer because it's going to update ERP and material documents are going to be created in ERP. Then when it comes to posting the difference on the bin level on the warehousing side, once you create a document counted posted, then you also have tolerance level there. Okay, so that tolerance level is basically when you correct the stock at bin level, it will check if the stock is up to the required tolerance limit or not. So if at all you have a difference of 100, okay, your bin quantity is 100, you have a difference of 100, that is 200. So you can say whether the difference of 100, if you have low, you will be able to post it. Also medium and high will be able to post it. But if the difference is 110, low will not be able to post it, medium and high will get an error, and medium and high will have to post it. Okay, so users in these transactions are assigned to the tolerance level. There is also a tolerance level for recount. That means if you assign tolerance level for recount as low, any difference above 100 will automatically go for a recount. Okay, so you have three tolerances basically. One for posting differences in the uh, bin level, one for posting differences at the uh, finance level, the difference analyzer bit. The third difference is for the third tolerance is for the recounting. If at all the tolerance is reached, recount document is auto created. So what we have to learn here is how to create a document, count it, post it, and also while doing that, you know, touch base on whatever the master data, and like these tolerances the master data for physical inventory, and what are the configurations required. So the configuration is let me show you the configuration and system. Let me first execute one process and then I will take you through the configuration, then it will make more sense to you. So we need to basically, remember one thing: we are counting the bins. Okay, so we have to backtrack. We have bins, and bins are within storage type. We have activity area. So there are settings related to physical inventory. So basically where those settings are done, we need to focus. So basically if we have, we are counting the storage bin. So setting can is not done at bin level. The physical inventory settings, basically the bin is assigned to a storage type. Okay, can be assigned to storage section as well, and is also assigned an activity area. So the settings are done at an activity area level. So activity area, it's a grouping of bins for performing a certain activity. So here the activity is physical inventory. You can group your bins. You can group the bins for the whole warehouse, and this activity area is using this. It is assigned to something called as physical inventory area. Okay, and we will see the settings for the physical inventory area. Okay. So we'll come back to the configuration, but let us see the process and system, then it will be easy for you to understand. So the transaction for physical inventory, there are several transactions: PI underscore create, PI underscore count, and PI underscore post. There are three separate transactions. I generally use PI underscore process, which gives me access to all the three steps in through one transaction itself. Okay. So let's say by default, if we are able to do any posting, if not, we will make some settings. Okay. So here you can see this is the screen where you create a physical inventory document. Now there are different types of physical inventory document. Okay. So we need to understand what are these as well. So these are the physical inventory procedures. Like you have different physical inventory, like you have different types of replenishment. Similarly, we have different physical inventory types. We call them as PI procedures. So we'll discuss them also. Okay. What are the difference? So the counting and posting steps are same, but how they are created, they are different. Okay. So as of now, let me say ad hoc physical inventory. That means unplanned physical inventory. And there are some planned physical inventories also. Okay. So I'm creating at a bin level. So physical inventories can be at PI creation levels, can be at product level, or it can be at bin level. So when I say product level, you can enter a product and count the product in all the bins, or you can select, you can select an aisle and count all the bins of the aisle. So you go to open search, you give your storage bin or you give your product, and you can find all the bins that match your criteria, and you can create a physical inventory document for that group. Okay. So for understanding physical inventory process, let us understand what bin we are going to count first. Let us agree on that, and then for that bin, let us see the stock in system. Storage type, let's say we take 8005. I'll show you several types of physical inventory. Let's start with another basic one where this bin has 10 pieces. Okay. So we go and enter the bin. That this bin we have to count, but before we enter the bin should have the activity area assigned, right? So you can see for physical inventory the activity area is, oh, there's no activity area, oh, INTL. Okay. So in the standard system, what we do is, let me delete the activity area first. In standard system, we have a generic activity area for all the warehouse. 001, for example. Let me sort the bins now. So if I refresh it now, you'll see this bin is assigned to inventory, physical inventory area 0001. That's the standard physical inventory area you'll find in SAP for physical inventory. So we don't maintain physical inventory settings. So when I said, you make settings here, so you can have 800125, 1:1 storage, 1:1 activity area equals to storage type. You can have that setting. But then again, you have to do the same physical inventory settings for all the storage types or all the activity areas. So what we do is we create one generic activity area, which is 0001. So I'm using the 0001 here. Okay. This generic activity area is applicable for, this activity area is applicable for, I mean, you can say, this area is applicable for all the raw materials or anything which is stored in this part of a warehouse. Okay. Or you can say this is applicable for the finished goods, this part of the warehouse. So you can group your storage types into activity areas, uh, that we have seen, but this grouping is more for physical inventory purpose. So let's say, we will group 1, 2, 3, 4, 5 into activity area 1. We have grouped, let's say we have grouped them as activity area 1. Okay. So let this activity area be assigned. We'll review the configuration. Make a note that we are not using the generic activity area for storage type. We are using generic activity area for physical inventory purpose. Okay. Generic activity area for PI. Okay. So this is what we need. The right activity area should be assigned to the bin. And then all the settings are at the activity area. So I'm assuming all the standard settings would be at activity area level. Let us create a document and see if the standard system has all the settings. If not, we'll maintain them. So you need to set flag and you need to, I'm not activating it now. I will save it first. So our first document is created. Okay, this is the create step. Now I want to go and count it. So I'll go into the edit tab. I'll show you what happens once it's created. What are the next steps? So we'll first see that into the edit tab. So when you are using this transaction through create, you can create, and edit, you can count it, post it, and any changes, even if you can delete, if you want to delete it, you can delete it from edit. Okay. Okay. So this physical inventory document is created. It is in inactive status. So you can see there is nothing here. Okay. So you can't even print it. Okay. So the next step would be to activate it. That means you can plan the physical inventory document in advance, and then they can stay in system till you want to actually go and count them. Okay. So here I activate and I will save it. So now if I want to go and count, you can see system has created a warehouse order. Let me show you this order. Warehouse order means we'll have to count on RF, right? So normally when you click a warehouse order, you will see warehouse task, but you don't see task here. You will see a PI document. Okay. So order can consist of task or PI document. Please make a note. Okay. So the queue internal is assigned. Let's make sure our resource is assigned to queue internal, and then let us go and on the bin on the scanner. You can also count it on the desktop, but generally, the users they count it on the scanner. Okay, because if it has to be on desktop, somebody has to go first print the document. So you hit by clicking on this print, you can print a physical inventory document, take the paper, go to the bin, count, and come back. It's better to count it on RF. Okay, inventory processes, internal processes, inventory counting manually. I'm entering my order here. You can also use queue wise counting as well. So here we go to the bin, we scan the bin. System is telling us this is a product in the bin. I say yes, this is the product. And then system is telling me, okay, enter how much quantity it has. I would say it has, physically it has, 10. I would say, sorry, system wise it has 10. I'll say it's 10 pieces, yeah. So I'll say 10 pieces. I'll say maybe 11 pieces, yeah. And then I will save my count. Okay, so once you count the document, you go into the scanner, go into the doc scanning, not scanner. Once you count on the scanner, you go to the desktop. You see the status has changed to counted. Okay, your warehouse order would be confirmed now. So why warehouse order is created? Because to enable you to count on the scanner. Okay, we understood the importance of queues, resources, and so on, and all are at warehouse order level. Okay, so now we counted it, but did it change the bin? It didn't change the bin. The bin quantity still remains as 10. Okay, so what I'm going to do now, I'm going to say post here. But before posting, let me make sure I have the required tolerances assigned to me. Underscore user is the transaction. So you can see there are no tolerance level assigned to me. So I assign myself a tolerance level. Okay, why it's not selecting. Let me do it again. EW, let me type it completely. Oh, that's strange. Finally. So I'm going to assign myself tolerance level of high. Okay, so in this system, there are two levels, clerk and supervisor. Please make a note of them. We'll go and see what are the levels assigned for clerk and supervisor in the config. Okay. So this is for the PA document creation, and if I want to recount automatically, today I don't want to recount automatically. I will show you how to create a recount manually, and then you can also automate it by maintaining a tolerance limit. Okay. Now the next tolerance is for the next tolerance is for defense analyzer for making posting to ERP system. So I'll say supervisor or supervisor. The other one also I should say supervisor. Supervisor will have more access than a clerk. Okay. So now we have maintained the tolerance limits. Now let us post it. Save it. So basically it will now post, and you can see all the timestamp when it has been created, counted and posted, and who did it. After posting, if you refresh, the stock quantity became 11. Excuse me. So now the bin stock is corrected, but you found extra there, critically going and counting. But has it updated MS? Has it updated the? Has it posted a material document? Because anytime we do a posting, in every time there is a stock adjustment in EWM, it will go and update ERP. So has it updated ERP today? Okay, so it has not updated ERP. So stock correction has not been done in ERP yet. So if you see the stock, it's for unrestricted stock. It is okay. So you can also count, quality block stock as well. Any stock type you can count. It is 1820 and 229 here. So here it should increase by, since we counted F2 stock, it should increase by 30. Okay, so for increasing the stock at the IM level, let us do the difference analysis. So I'm going to run it blank. Oops, what happened? Why this document is created? Okay, so this is minus F2 11, and this is plus. Just would like to understand. Really, I'm expecting there should be just one line here. It is saying it is adding 10. So this is like a debit credit. The stock has been credited here and debited in your stock account. So now it has to be adjusted by posting an ERP. So we removed 10. We we added 11. We removed 10. But I'm expecting it should be one line. Let me see what is the difference here. The system has created two lines. Product is same. Okay. You can see when I entered the count, I replaced carton by pieces. Okay, so that's why it's trying to post and say, you are removing, you're not having any more cartons in systems. Okay, so this material 10 pieces equals to 2.5 cartons. I said, I just have 11 pieces, I don't have cartons. So it has replaced, you know, 2.5 carton with 11 piece. So a different stock unit has been created. That's fine, we will do the posting and I'll say yes, yes, and it has cleared. Let us see what has happened in the stock in ERP. Has it updated? Not yet. See, now it has updated. It has gone to 30. And you can see a material document would also get created now. It's posted with 711 and 712 because it removed the quantity in cartons, saying that you don't have cartons, and then it added stock into pieces. Okay, so it removed minus 10 and added plus 11. Okay, so whenever we add stock into the plant, it's 712. Whenever we remove stock, it is 711. Okay, so these are the movements which will happen in system. These are the basic steps of physical inventory. We will now do some more physical inventory documents. Let's say we do a recount, we count at a handling unit level, and then we'll go and see the configuration. Okay, so we'll see a couple of more variants. But before we go ahead, any questions from anyone? Are we clear so far?
No, Ron, we got it.
Okay, give me 2 minutes. I'll be back. I'll have some water and come. Just give me 2 minutes. Okay, I'm back. So, hmm, let's go now and create another physical unit. This time we are going to count a handling unit. Okay. So let me see some stock. And 8001 or 8002. So this first stock was without handling units. So now I would like to show you how you can count handling units. Other steps are same, and then I would also show you how to create a recount document. If you counted something and you would like to recount it, how do you do that? Okay, so we have these handling units, these bins. Let me say I want to count this bin. Okay, just make sure it is assigned to the right activity area. 001. Okay, I'll go and create a document. Created, new, enter the bin, set flag. This time I'll say directly activated. So it will automatically get created, activated, and the warehouse order would get created now. The order is 2118. And here, if you now go to the RF, I would say, okay, so you can also create a documents through RF, ad hoc documents. I've created them on the scanner. So you can say system guided. System tell me what bin to count. System is telling me to count this bin. And then here you can see the screen is slightly different. Here you can see the handling unit. So when you're counting the handling unit, you go to the bin, you see the handling unit, you scan the handling unit. Okay, and then what do you want to do? Do you? So first of all, I go to the bin. If I see the handling unit, I'll scan the handling unit. I'll press enter, and then I'll enter what quantity is there within the handling unit. Let's say one piece. Okay, and then I will save it. Okay, but what if there is another? See, there is another good feature in it's counted. Do you want to leave counting? Yes, I didn't save it. So there is another good feature in counting, especially with handling units. You go inside, you have been asked to count the handling unit. You go there and you say the bin is empty. Okay, that is also applicable for non-HU. You don't see the handling unit there, or you say the HU is there, but the HU is empty. There's no stock in that handling unit. Okay, or there's a third option called as HU complete. That means you go there, you see the handling unit, and you say yes, that's the PI process complete. I cannot go within the handling unit and count the material. Okay, so I cannot count the material because the pallet may be wrapped into bubble paper. Sometimes you pack your pallet to send it to customer. The label says 50 or 40, whatever. You go ahead with that. You don't want to count, you don't want to open and count, or you're just checking the existence of a pallet in that bin. You don't want to count the product in that bin. Okay, so you would scan the pallet and say HU complete. You will not take it down on the floor open and take out all the products and count it, right? So there are these kind of challenges in handling units. That is why SAP has given us this HUMT, HU complete indicators. Okay, so for now I'll say bin empty. Okay, let's see what system has done here. Refresh, and you can see system would add the difference here. The entire handling unit it is showing is as a difference. So book inventory was this, and this 8 pieces of T-T 300, but we said it's empty. So it is showing us minus here. So what we are going to do now, we are going to do a posting, or else I'm a supervisor. Let me say, hey, I don't see handling unit can be missing in the warehouse. Can you please cross check? I will just say recount. I would save it. Okay. So the moment you do a recount, okay, system completes this document and creates a new document. So new document number has been created for the same bin. Okay. Now again, you can see that again you can start the process again. Okay, that document got closed. This time I will count it on the. So I told somebody to go and check physically, and this time I'm going to count it on the desktop itself. Okay. So here I would say, yeah, the bin is empty or it is complete empty, missing. Whatever it is, you can enter here. That person tells me, hey, HU is still empty. Yeah, the bin is still empty. Put it as enter, and I would save it. So you can also do the same counting on your desktop as well. Ideally, you would not use desktop because the main benefit of counting is on the scanner. Okay, and you do the posting. Then it will appear in difference analyzer, and you can do a cumulative posting and from the difference analyzer as well. Okay, so let us clear a difference analyzer also, just to make sure our system is consistent. ERP EWM stocks are consistent. I will make a post here. Okay, that's done. It would have then posted in ERP as well. So in all this process, we saw, from a configuration or setup point of view, just one thing, a new activity area, because we are grouping different storage types. Even 8002 had activity area 0001, 8005 also had activity area 0001. So we have these activity areas, and let us see how the activity area, along with physical inventory area, there is something called as physical inventory area, how it helps to maintain the different configuration for physical inventory. Okay, so I haven't discussed printing because we'll discuss that tomorrow in our PPF topic. Let me explain you about this. Uh, Anything related to prints and outputs in SAP EWM, we'll explain that tomorrow in detail. So here you can see these are the configuration. The first and the most easiest thing, your tolerance level, high, medium, low. You can configure here. So for the clerk, it had WS35 clerk had 10,000 as the limit, and supervisor had unlimited limit. Yeah, no tolerance level. So you can create your tolerance levels here, and you can then go and assign them in SCWM PI underscore user and PI underscore user underscore diff transactions. Okay. Then in the physical inventory, you have several reasons. You can put your own reasons, custom reasons, Z reasons you can create and assign it. So basically, when you create a PI document, standard SAP will assign it the reason for creation. But if you have some specific reason, business reason for creating a document, you can go and change it. So you can also configure these reasons if you want. Okay. So otherwise it will have standard or unplanned, two things. Okay, then the main config is the activity area. So here you can see assign physical inventory area to an activity area. So for physical inventory, you will see the warehouse is WS35, activity area is 0001. So in activity area, we have done the configuration, right? What are the configurations required to assign activity area to a bin? Okay, so you can see that in the notes that we discussed in activity area, we have created an activity area 0001. It is assigned to storage types 821 80012345, and then when I'm sorting it, the activity area gets assigned to the bins. Okay, so this is what we have already covered. New thing is the physical inventory area level. What is physical inventory area? So activity areas are assigned to physical inventory area, and you can find the physical inventory area specific settings here. This is the, sorry, not physical area, physical inventory area related settings. You can find it here. So this is the most important place where the configs are done. Okay, so see here you can say, you can activate different settings. Okay, whether you want to do a printing of objects, whether you want to do HU complete, which I showed you. There's something called a display object. So display object means if you're counting a GI area or a good asset area, or if you're counting a stock which is assigned to inspection document, you can see the document number, on the screen. If you want system to propose you quantity, display quantity, we don't ideally do that because we don't want users to know what is there in the bin. Otherwise, they would not count. They might sometimes enter the same thing. Okay. So posting after count. This is very useful for the bigger warehouse, faster warehouses. See, somebody is counting and then somebody is posting on the background. If the difference is under 10%, I would say, like, as if I count and if I have the tolerance of, let's say, a tolerance to port difference up to 100 euros. So the moment I count it, it should be auto posted. Okay. So this indicator can be used for that. Then you have other indicators like low stock, put away, low stock check, put away PI. So these are some physical inventory procedures. Okay. So you have these plus these. Okay, the procedures that I've written down. So you also have something called as a low stock check, and you also have a PI document of API. Yeah. Okay, so I'll explain you what are these. So these are different types of physical inventory processes. Okay, so we'll discuss the procedures. Okay, and then there are settings here which is independent to physical inventory area. These are settings related to warehouse, where you can give your physical inventory variant, your calendar. You you want to say that the owner party entitled to dispose should be proposed. No, users don't have to put them as an input on scanning. Okay, number range of the PI document is here, and if you want system to do a tolerance check, okay, in counting. So if I'm counting and if the tolerance is exceeded, I should get a warning message. If it is about 10%, if I want to give that, I can do it here. If I don't want, then generally we don't let the users know whether they are doing correct or wrong, because their counting should not get impacted by any system inputs. So these are some of the settings you can do it at a warehouse level. So we are now going towards discussion on the procedures. Okay. Okay, do I have the procedures here? Okay, it's not there. Let me explain it. So for now, PI creation level, I'll just show you. I created a document referring to a bin. You can create a document referring to a product as well. For that, you need to say ad hoc, as ad hoc means unplanned. We are just not planning this in advance. There is some sort of planning, or at a different interval we do the other checks. I'll explain you that. So I'll do a product based. I would say enter product. Okay, so you do execute, these types. There are several types. Do execute and see how they work. So then, if there is this is a critical part, and consistently, there is an issue with this part. So I would go and select this part in all the bins, set the indicator, count it, and then count it in all the bins. So this is, see, what people do generally. The whole warehouse they count once a year, but they do count certain products, critical products throughout the year. So here, I'm selecting the product manually and doing a count. You can also do a cycle counting, where system will check whether the product is A product, B product, or C product, and it will propose you for counting based on the interval that you have maintained. So A product will be counted every month, B may be counted, let's say, every quarter, C may be counted once a year. So you can use this product counting, or you can maintain ABC indicator in your product master. This is similar to what you do in inventory management as well. So the ABC indicator, you will find it here, cycle counting indicator. And the transaction to create a cycle counting document is PI underscore CC underscore create. I hope I'm right. Yeah, using this, you schedule this as a batch job run, and it will check the products which are ABC and check when they were last counted. And based on the frequency, if they are, let's say, A is not counted within a month, it will create a document. Okay, so you can automate the document creation through cycle counting. Okay, so you have product based, you can manually enter anything and count, and you can also do a cycle counting as well. Okay, so we saw, you can enter a product, count all the bins of the product. We have been discussing about, okay, we have been discussing about the unplanned physical inventory. Unplanned or ad hoc. Ad hoc means something which is unplanned. So when we do ad hoc, basically, you know, anytime during the year, like once a year, I'm going to count my whole warehouse. That is a minimum requirement. So generally, we have shutdowns in the plant, and for 2 3 days, and then we do entire counting. So this physical inventory procedure, the counting that we do in the warehouse, we uh, you know we do that as part of annual physical inventory. And in annual physical inventory, when you're closing down the plant and you're doing physical inventory, in that time you will create a document with these two procedures. Okay, that is your annual physical inventory. That means annually you're going to, and as a annual process, you're going to count them, all the bins. You're going to count them annually. Ad hoc is anytime during the year, take any product, take any bin, count it. Okay, so sometimes ad hocs are also required when we um, Docs are also required when we see something, some bin is damaged or some aisle, it is going for some maintenance, and once it comes back, you want to make sure everything is clean. So you do a physical inventory after reposting the stock. Or if you feel there is one aisle where you're consistently getting differences, you can take that aisle and do a physical inventory process. There's something called a storage bin check. See, this is not, I would not say this is a kind of physical inventory document. It's just it just makes sure the product is there in the right location. Okay, it doesn't goes at a counting level. So it just checks whether, and the scanner will just tell you the product is there or not, yes or no, that's it. It doesn't do counting at a quantity level. Okay, but yeah, if you just want to do that check, you can use this storage bin check. Okay, low stock check and put away PI are other two PI processes. Okay, I'm just giving names, they are not given any code in SAP. So what happens with them? Um, See, low stock check and put away PI, it is generally, these are generally executed along with your day-to-day business operations. See what happens in physical inventory. You're either shutting down the business, or waiting for business to shut down, or every day you are planning certain bins. But you know, there is one important point here. Like, you have to have a dedicated team for PI and who are regularly doing the physical inventory. You have to plan these stuffs. But what happens is, if you go and count a bin, okay, or go and pick a metal from a bin, and you realize that there is a difference. Okay, so low stock check basically what it does, it tells you, it basically, it's a physical inventory, process during counting, during the picking process. Let me explain you. So what happens is, there is a something called as threshold quantity. I go to a bin, I pick my material. Okay, generally when we pick, we scan the source bin, product quantity, we scan the destination bin, our picking process is completed. But here, if you activate low stock check, there is another step which happens. Okay, so my low stock check, let's say I've said, if the stock in any bin goes down below 10, just let us do the counting. Okay, so when I go to the bin, if the material is 20, I pick 15 out of it, the stock becomes 5. The stock is below the minimum quantity. So system gives me a pop-up. Hey, your stock is gone below low check or below the low limit. Can you enter what quantity you see in your bin? I'll say I can see 5. Oh, that's it. No, nothing that no action required. We just verified yes, everything is okay. But let's say there is, as per system it is 20, I pick 15. It gave me a pop-up. Hey, what is the stock of the remaining product in the bin? I go physically, I counted, I see, hey, there are 7 in the bin. So I enter 7. So when I enter 7, the stock in the bin gets automatically adjusted to 7 and it goes into difference analyzer. So what happened is I counted the stock while I'm executing my picking. Okay. So there is something called a zero stock check also. That means anytime a bin becomes empty, we get a pop-up. Hey, do you see any stock in the bin? Enter the quantity. I say, yes, I have stock. I can see 4 pieces. Enter the quantity accordingly. The the bin stock gets updated. Okay. Similarly, in put away also you can do that. First time you do a put away in a bin in a financial year, after doing put away, it gives you a pop-up. Hey, what is the quantity after put away in the bin? I said it was 10. I added 10. It's 20. I'll say 20. That's fine. If I say 21, system will go and make a physical inventory posting, change the bin from 20 to 21. Okay, so this low stock check you can activate and see how it works. What I have done is I will just show you, the only difference here is the screen which comes up. So you can activate and during picking you can see how that pop-up screen comes up. I'll just show you here with an example how the screen looks. Yeah, this is the screen that comes up. Screen looks something like this. So I'm counting the bin, counting the stock in the bin. I picked up six. The stock went down below minimum, below the low limit, and you can see a pop-up came. Hey, what is the remaining quantity? I entered three, and accordingly, the stock gets corrected in the bin. It should have been six, but or four, but I've changed it to three. So you can go through the low stock check in this document and also try it by yourself. It is a it's a very useful process. But yeah, some businesses they don't like this because they lose the traceability. There are too many postings where they don't, you know, too many postings where it happens unplanned. There may be some bins with faster products, like with too much quantity of product, they may not even go below the minimum quantity. So the minimum quantity in the bin is 10, it may not go down below 10 at all. Okay, so those bins may never get counted. So it becomes difficult to manage for certain types of bins. But yeah, if for faster moving the bins which continuously get refilled up, those kind of bins you can use this counting. Just saves time in doing a separate counting, separate planning counting for your bins. Okay, so this was physical inventory process, and I want you to do a product based, bin specific, product based, do a low stock check, do a cycle counting, and see how it works. For all these procedures that I've discussed, the the difference is only the PI document creation. The counting and posting on RF is the same. Yeah. So for I'm talking about these ones, the ones which I've highlighted, their counting and posting is same. Only the difference is you select a different procedure for creating a document. Okay. So any questions on the PI process, physical inventory process? Anything anybody would like to discuss? Yes, Arjun, Dinesh, any questions for me?
No, Ron, no from my side.
Okay, okay. Hmm, right. Okay, then. Then let's move on to our last unit, which is cross-process topics. Okay. So out of these, I'll be taking PPF actions tomorrow. But let me see, what I can cover today. So PPF action is a bit technical, so I would like to do it with a fresh mind tomorrow. So let me say unit 10, unit 11. I think physical inventory was a separate unit I've included in 9, unit 10, 11, okay. So let's start with, the so okay, before we start, I would like to say, that the labor management and MFS, we may not be able to test them thoroughly because they are dependent on a lot of external systems or external interfaces. Okay, so labor management, it has to be integrated with HR, and we need some labor standards. So we'll not be able to test them, but I will give you an overview in from an exam perspective also. Whatever you need to know, I'll explain you, and whatever the uh, my experience while implementing this process, I'll share with you. Um, for the others, we will try to see them in system. So um, we'll start, let's say, with validated service and kitting. Okay, so let's see if we can cover cross-docking today and PPF action. Let's see, if time permits, we'll complete all the topics tomorrow. If not, we will connect again next week. Okay. So let me discuss with valued service and kitting. So before we go into these things, these cross topics, see what I want you to make sure that you have first completed all the basics, what we have covered, basic processes by now, basics and advanced processes by now. Go through them thoroughly, and practice them. Uh, Come to cross process settings at the end. Okay, you can consider this as optional because things like VAS, kitting, labor management, cross-docking, they are not implemented in all the companies. Very few companies will go for it. But whatever we have covered so far, physical inventory, replenishment, almost every warehouse you'll get those kind of processes. Okay, so make sure you're thorough with that. This these are advanced functionalities. You will require a lot of settings, and you require detail. I'm going into more detail, but you know from my application point of view, I don't see many companies using this. Apart from PPF, the others I'm saying, very less companies they use this. But if you know the other topics, these topics you can quickly catch up. So first focus on the others, and once you're through with those, then you can start on these validated service and kitting. Okay. So validated service and kitting. So basically, okay, let me explain you what we covered in our outbound process. Okay, so in our outbound process, we did picking, packing, staging, loading. We did a POSC. Okay, so last complex process for inbound and outbound we did was with POSC. Okay, now this validated service and kitting. Let's start. They are independent topics. I tried to club them so that in one execution we could see both. So what happens with validated service? So system basically, it creates a warehouse. Basically, it creates um, a validated service order. Okay, and for that validated service order, we execute the service there. So, in our POSCs for inbound and outbound, okay, what were the validated services that we did? Okay, we did packing. Okay, we did the deconsolidation. Okay, others were not validated services, right? Because um, staging is not, you're not doing anything on the product, right? It's a process requirement. But wherever you are doing some survey, some actions on the product, you are labeling the product, or you're applying oil or repacking it, anywhere you apply some, wherever you execute some activity, let me say whenever you do some activity at a work center, okay, that is your validated service activity, activity of value to your product. Okay, so so these validated service activities can be tracked further, or can be, see, this itself becomes a very big process, picking, then packing, and then staging, loading goods issue. But some warehouses would like to go into this in more detail, in the packing or the deconsolidation, whatever you do at the work center. They would like to see what time was required, what parts were consumed. Let's say, some company, they are supplying equipment, medical equipment, where they are doing very detailed packing. They want to see all those levels of packing, and there are put this manual, do that, everything they should see on the system. What all steps are involved in packing, and they may consume a lot of packaging material. They would like to track the packaging material is very costly. They would like to track how much material got consumed for which packing, which delivery packing. Okay. We call them as auxiliary material, auxiliary packaging material. So these activity that we do at a work center, we go in a detail level. We do them using value-added service order. Okay, there is an order created. So when we are using POSC, we do a pick, pack, stage, load. So in the packing step, we would also in the packing step we just did packing completion and we completed our process test. But here we would also do another step after packing. We would also declare what time it took, what time it ended. We will be able to see the instructions on the screen, and then we will be able to when we post the difference, when we post the auxiliary counting, it will update the system. Okay, so you you can do packing at a more detailed level and at a more you can create a separate order for that. Okay, so that becomes a validated service order. So we're going to see how a validated service order looks like, but we're not going to see that for packing deconsolidation, which we have already covered. We'll see for a process, a validated service called as validated service process called as kitting. What is kitting? Kitting is preparation of kits. So there are two types of kits: kit to order, kit to stock. Okay, so you make the product in kits and you store them in your warehouse, or you pick the product as a kit and then supply to your customer. So let's say we have we have typically kits are very common in the automobile industry. So whenever the customer needs brake, they don't order brake, they order entire brake assembly, right? Where you get all the bushes and all the clamps and everything along with the brakes. So 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 brake, it is part of five six. It is brake assembly is part of five six components. So you always those components are stored together, issued together. Okay, so it's a basically a kit and that is made. Okay, so let me show you a kit example. Okay, never mind. I thought I had a screenshot. Okay. So the kits, they are it's like a bill of material. Okay, you make a kit and you store it into the warehouse. Okay, or you make a kit, you store in. Let's say there are two options when you pick a kits. When you make kits, one is you prepare kits, store them into the warehouse, that becomes a kit to stock. The other one is kit to order, where you are storing these 12 components, 8 or 12 components, whatever, in different bins. A customer told you give me one brake assembly, and then you start picking those material. You prepare a kit and then you send it to the customer. Okay, so you're preparing a kit while you're picking the part. Okay, so you pick a part into a pallet and then you make it as a kit. So our aim in this kitting is to see how kits look like in system. So kit is nothing but a bill of material. Okay, from a customer point of view, if you are sending it to customer, or from a storage point of view, if you are just making kits and storing them into the warehouse. So basically, here there is integration between SD and integration between PP. So first of all, this bill of material, EWM does not store any bill of material. Okay, so when we are doing kit to order, okay, we are supplying parts in kitted form to a customer. So the bill of material should come to EWM via delivery, and it should come via sale order. So there is something called as kit bomb, which is there in the sale order. Okay, the kit bombs first flows from sale order to you know the urban delivery to EWM. So basically, there is, in production order, there is bomb explosion. Similarly, there is bomb explosion uh, in the sale order. So when you create a sale order, if the customer's ordered bake assembly, system will read the bill of material, add the components. These components will pass to the urban delivery and then to EWM, and then EWM will pick the components and make a kit. So in EWM, the only difference is, so you have learned the POSC. The only difference is you take the components to a work center and you prepare you say process step complete after your packing the components. You also say prepare a kit. So you will see a assembly kind of a structure in EWM. That's it. Then you stage and goods issue. Okay. So for kitting, everything comes from ERP. Okay. The BOM is in ERP and EWM. Very important for EWM is that the BOM structure should come from ERP. Then only our process will run. So basically the item categories wise system knows this is a header, this is item, and will allow us to make a kit. So I'm going to show you how in this system there, for another warehouse, I asked the sales team to create a kit order, sale order. I'll show you that. So we'll see, how a kit order is created and how it goes to EWM, and then how we pack and prepare a kit, how kit looks like in EWM. So we are going to do kit to order. And then, similarly, there is kit to stock as well, where, based on production, they will make a kit and then we do the good receipt and put away. So the production order will be created, it will have bill of material, and that will be a kit assembly production order. So all the components will be taken to a work center. Okay, like we do a production supply, we take all the components to the work center, and there we, rather than manufacturing, we do the packing, complete the step, prepare kit, put away into the warehouse. Okay, so like we did a production integration, we can do a kit to stock as well. So you can store the kits into your warehouse as well. Okay, so kit to order is more common because you don't want to prepare kits. Let's say you know based only on customer order you would send. So these components could be used across multiple kits, right? Multiple kits. So let's say bolts, screws, your clamps, they are used across multiple kits. Why? Let's say if there is demand for another kit, we have locked this product into a certain kits. So generally we try to use kit to order because that way the products are not locked against a kit. They can be picked as and when the demand comes. Okay. So kitting, preparing a kit is nothing but a packing based on the bill of material in the sale order, and then we are going to see while we are preparing kit how we can also look at how a validated service order looks like. So we have done packing, several packings. Now we will see how packing with um, a validated service order looks like. So we'll see packing, but we'll also see an order. We'll see packing for kitting, and we'll also see an order where we can see what are the additional steps required to be done when we are performing a validated service order. Okay, so while we execute kit to order, I have also activated the while I've also added the uh, validated service so that we can see both of them together. Okay, so here we'll execute the process. There is some configuration master data. See the for validated service kitting, there is small activation here and there. We need a pack spec. We need the delivery type, item type. We should say, determination of validated service order. So, so all this configuration master data are there in the document. I leave it to you to explore whenever you are free. It is similar to what we did in POSC. Okay, some 4 5 settings are there. All the master data, pack specs, and all we have already covered. Just there is variation in pack spec. There is a different condition record. Okay, that you need to maintain. So in the work center, it's a service work center. You have to make sure the right work center layout is assigned, right indicators are maintained. So you can compare that with what I have done in that warehouse. Okay. So let's do that. Let's execute Git. Once we it's an add-on to your POSC to POC, you can choose whether you can go with a value service order or not, whether your business process requires kitting or not, and then you can activate for your business as and when it's required. Okay. All right. So let me try to figure out, the old mm, warehouse where we created a kit. Just bear with me for some time. Yeah. See, this is a kitted order. I generally use this for my testing. So you can see there are components, and there's a header material. These are the components. So for this, it's very important the sale order is correct. Okay, we are using the right sale order, and I would take that order number 46, and I would create a delivery out of it. Okay, well, let me show you the order. So see, this is the main part, and these are the components. So when you create an order for T-B400, these components get added. Okay, and what is important in the sale order is the right item category. Okay, so everything moves around, item category. So see, this is kit header, KITH, and CMP are the components. Okay, so in this one, this sale order based on the item category. I think you can, if you want, you can also T-B400 CO03. Sorry, CS03. That's a bill of material. T-B400. You can also see the bill of material here. So generally we do production. This bill of material is for sales. See, these are the components. Okay. Now what I'm going to do is I'm going to create a delivery. So this header material and the components will be moved to EWM. Sorry, the shipping point should be let me look at the shipping point here somewhere. Oh, this warehouse. It is shipping houses C1123. Okay. The shipping point is 1710. Okay. Let's use 1710. Okay, so let's put a quantity here. Okay, and a store location. A similar setup, these are similar material for a warehouse. It has similar setup. I would say I need one kit, and for that, the two components also need one quantity. Okay, let me keep it simple. Okay, and I would save it. So make a note of the item category. Okay, everything. If while you're doing it, setting this up for a warehouse, make sure, or in your projects, make sure you get the right item category here. This right item category determination, KITS, COMP, these are standard ones. If you get this determined, half of your job is done, because EWM knows this is header, this is component, by looking at the item category. Okay, so if you see this delivery in EWM, system knows that this is a header material, this is item material, by looking at the item category. So if you look here, the header KITH is mapped to OKM, and the component COMP is mapped to OKC. So that way system knows that these are child and this is header. Okay. So now we would take the components to a kitting work center, and we'll do kitting, we'll make a kit, and then we'll goods issue the kit. So our aim is to see how kits are seen. So the important thing we understood is EWM doesn't store any bill of material, it should come from ERP, and EWM prepare kits in the work center. That's what we are going to see. So here, what I have done is I've also used this master data to create a validated service order. Okay, so you can see a validated service order is created. So for validated service order to be created, pack spec is important. So this pack spec is created. So you can see the pack spec. We have seen INB, OIBD, and other pack spec condition type. For validated service, it is OVSO. Okay, this is the condition type. Okay, so then we have POSC also. The step is to be assigned. The step has to be I have assigned here is VSKS. Okay, so you can look into the storage process and see how that step is assigned. Okay, so we got this warehouse validated service order created. That's created in background as soon as you create a as soon as you do a delivery creation. It creates a validated service in background. So this is, I'm just showing you for kitting. We are just doing kitting, so you can also do validated service for inbound, outbound, kit to order, reverse kitting, internal process. You can do it for several types of processes. System will create similar order. Okay, even for outbound POSC, outbound or inbound POSC, you can create a validated service order for packing and deconsolidation. It will look similar. Okay, so from item you can go and see your order, validated service order. Okay, now it's time to pick an item. Okay, so let's see whether system picks the child items or only the header. When I go and start creating a task, you will see system has not picked item 10 because that's a header material and these are the components. Say create. I say create, you can see it is creating, it has found stock, and two tasks are created, the components are picked, and they are taken to the kitting work center. I've created a new storage type 8060 for kitting. They are taken there. Okay, so we know in POSC how we can determine intermediate step. Where do we determine intermediate step, and where do we assign the which location for that intermediate step? Okay, so everything remains the same like how we did in POSC. So let's say confirm it here. Okay, I'll confirm it here. So I have supplied my components to the kitting work center. Okay. Now you have to go to the kitting work center and perform kitting. So you can go through a transaction. There's a separate transaction. I directly like to go from the work center navigation from here itself. And this is how it looks. So this bottom thing is your validate service order. So validate service name look big fancy, but it's nothing but addition of this section in the work center. That's it. And basically what it does, if you click this order, it may be important for some, companies, but others it may be, with bigger, faster warehouses, this may be, kind of overhead for them, right? Just to complete another order all the time. So let's say I'm the kit preparation. I'm the clerk who does the kit preparation. I'll come here. I'll see the pack spec. I'll see, okay, what has on my big screen. I would see the pack spec that has to be, what packing has to be done, what components are involved, all those things I'll see here. I'll say, okay, now let me start. So here I would record, the time interval. Okay, so I would do something like this. I'll say start. So the start time gets recorded, and when I'm finishing, the end time also gets recorded. That can be used in your reporting. Okay, now here I will see, okay, I need these two products. I take the products, I start packing them, preparing a kit. I do the label printing, whatever is required, and then if there are any auxiliary products, that quantity I have to consume, like bubble wraps or polythenes or any other, thermocols, I would put their quantity here. If I have to post any components, I can do it here. Okay, so here basically they will now follow these instructions in the pack spec, and they do the packing, and any consumption will be recorded here in this tab. I have not added any valid service auxiliary material, so that's why they're not appearing here, but you can add if you want. Okay. So once you're done, you will say end with a variance, but let's say we are still doing it. Now while doing it, I have packed it into a pallet. Let's say Euro pallet. Pack this component, prepare them into a kit, and pack them into a Euro pallet. Okay. So for kit, handling units are mandatory. Okay. So I have prepared a handling unit, pack them, and let's say my packing operation is completed now. And then I would say, so what we are doing, once we complete the step, we say step is completed. But before that, for kitting, we have this another option called as generate kits. So this is the only difference compared to your picking, that we do it in kitting. A normal, outbound picking, this is the only step that we do in addition in kitting. So you can see when I said generate kit, a assembly kind of structure is made. So your header got added and your components also went into that header. Okay, so now when you goods issue, this material will be goods issued, and this will be added into inventory, and it will be goods issued from here. So the client will be billed for this, the cost of this. Okay, so in this process there is sufficient amount of sales settings as well, right from what should be invoiced, what accounting entries are required to be posted, and so on. Okay, so now we prepared a kit, and this kit you can store it in the warehouse, you can do staging, you can goods issue it. At this moment, this step we'll complete this step. Okay, it's already completed since I generated the kit, and the valid service order is also confirmed. So in kitting and valid service is, kitting is addition of this with all the master data from ERP and valid services, a new order here, your ability to record any difference of consumption of your components, valued service auxiliary products, and also recording the time here. Okay, so this way we can work with kits. I Since this work center, kitting work center, I have also marked it as a goods issue as a staging area. So I'll directly goods issue it from the kitting work center itself. So I'll not take it to staging. Let's say I made a kit and from there itself I send it to my customer. So I will be able to do the goods issue. If you remember, we said work centers are also work center can also be um, staging areas. I've done in the kitting, I've marked it as a staging area also, and I've been able to do the goods issue now. Okay. Hmm. So that's how, this is just an execution to give you an overview about this. There are many more things depending on your client requirement you can explore further. All the documents, I've shared has all the steps required for executing the process. So do execute this and see, how order looks like and how the kits are generated. Okay. So any questions on the kitting process, validated service process? Okay. If no question, then shall we take a quick 5 minutes break and then we can come back and cover the other topic?
Sure, Ron.
So it's 1:18. Let's come back around 1:25. Hello, shall we start?
Yes, Ron.
All right. So now we would be discussing about which topic do we take? So let me, give you an overview about labor management and MFS. So, all right, what is MFS? So MFS, let me start with MFS first. Okay, so MFS is basically used for the automated storage and retrieval systems in warehouse. So here you can see, we have conveyors, we have these very small narrow aisles where there are, robots or, stacker cranes and all kind of automated devices are used, equipments are used to store and remove the products. So this is where, you have automation. Most of the warehouses, the high racks and, certain areas of the warehouse, they have, it's an automated equipments are there. So how do we integrate that to the EWM? So, these racks, they can automated racks, they are control units. We call them as PLC. They can communicate directly with SAP. Okay, that's where the main benefit is. So, let's say we are implementing EWM. Then in EWM we have to uh, implement warehouse management for this automated system or automated storage travel area. So this is automated area. So what happens is, there are two options. One, we go to the person who is implementing this, who is installing this. He will have, there are limit switches, sensors here. So that's through, and there is a control unit. So there is signal, which they get, and there are signals, which there are some, um, a lot of data they have related to which part is there, which part is moving from where to where, and um, you know and they direct basically, the conveyor and the cranes to move from one location to another. Okay, so basically in this case, there are two options. One, we as we go for SAP EWM. Okay, just give me a minute. So here, we can decide that we can here we can decide that, we go with SAP EWM. That means, in these bin locations you would see that in SAP. Okay, and all these movements from, let's say this is a communication point from here to the final bin, those movements you can track it in system. Okay, the execution will be done by these automated systems. This is one approach where we implement MFS. There is another approach where, the manufacturer says, hey, I have my own system. You just give me, when you're entering the automated system, just give me the pallet number, and that's it. I'll put it into the right location and confirm you back once I put it. So basically, this is called as a black box system, where everything is done by the company themselves. We don't see all the bins. We do not see all the racking bins and which product is in which bin. Basically, we give the order. So there is a put away order to put it into, let's say, open storage. We give that order to that company system. That order is sent by IDOC, they confirm it, and then they confirm us back saying we placed it into this bin. So this kind of setup we call it as the warehouse control unit, where everything you are you know passing on every management of this entire unit, the IT or you know the ERP side, you're giving it to the company who's installing it. They have their own softwares. So what are the benefits of that? The benefits are like, when we use these kind of systems, they have, they have probably they are more flexible as compared to SAP. So any changes, they have better information on the physical equipments. Like, if the conveyor has failed, there's a fault, to stop sending the message. So they'll send us a message that now don't send us an order, or there's a delay. The orders will get accumulated, and once the machine starts, then the orders will start processing. Okay, so they have their industrial experience and implementation experience, and then the many most of the company, they go with that black box approach, where we send the IDOC, they store, and then they give us back. But let's say what SAP says is, why you need two separate softwares. We can also go and manage these units. So what their software does, it talks to those PLCs and conveyors, those units. So we can also go and talk to them directly. So you know we can the benefit that we get is, we can track material exactly where it is in this storage system, and we can also track in which bin. In other case, you cannot track all the bins. It's an integration. It's like a, how do you interface? It's like a interface in the warehouse. There's a company called Logia that does that. There are many other companies, that they have their own software, and then they prefer to use their own software. Sometimes they may give that software for 5 years for free, okay, along with the installation. But where SAP MFS comes in is, you don't. The challenges are, there is an interface, there's an IDOC, there are chances of interface being down, too much dependency, plus extra license cost for that other software. So what SAP says is, with SAP EWM, you can use EWM, and we will communicate directly with this PLCs, and through PLC to the sensors, and we will give them the inputs where to take the part, and then you get a message back from them when the part is confirmed, when the part is stored in the final place. So what we achieve here is, you get detailed information about the storage unit, where the part is, which resource is handling it, and which bin it is getting stored. So you get entire warehouse traceability. So the main aim of warehouse management is to have a bin level traceability. So if this automated system itself is not in EWM with black box, you will not have that traceability. But when we have this kind of a setup with MFS, you get that traceability. So that is the main advantage of MFS. Then MFS doesn't use this IDOC to communicate to these PLCs and all. They communicates through something called as telegram message. Okay. I'll show you how a telegram message looks like. So it's basically, MFS basically is everything about what we have already covered. It's just think about those things. You take a material without MFS, you take it into a drop point, a staging area, like we created W1A and WI1. It stays there, and from there it goes to the final bin. So similarly, your drop point, similar to that, could be your communication point, where you drop a pallet. From there it is taken on a conveyor, and then finally it dropped in the end of a conveyor. Then some automated equipment picks it up and then stores it into the racks. Okay, so all these messages, like, yeah, the pallet is here, a telegram goes to them. They take the material from here, move it to the next place, and then they send us a telegram. Yes, the step is completed. And then when they store it into the final bin, they again send us a message: the pallet is into so and so bin. So telegram messages are light as compared to IDOC, and it's not. We don't need any coding as such. Just like to read an IDOC on the receiving side, but we need something like reading the message, the flat file of Telegram, and putting that into the PLCs, so that they understand our code and they can execute the movement. So just to give you a brief background, SAP, what we are talking about, SAP directly talks to the PLCs, that is through something called as ABAP push channel TCP. That is the latest advanced feature in EWM. But talking to these PLCs had been a very challenge over a period of years. So we used to have third-party MFS, some third-party middlewares. Then SAP started its own middleware with an adapter. So we still needed an adapter. And then SAP with EWM took away that third-party MFS TRM and brought it into EWM. But we still needed an adapter. Adapter means you needed an installation on NetWeaver so that you could send a message to some PLCs outside of SAP. But now with ABAP push channel, you can directly send message to a PLC IP. Okay, so messages are sent. So tasks are created. Functionally, there is not function. There is not much change. You know how to create a task. Just create your role configuration and everything as you would do in a normal inbound and outbound. But certain tasks are not to be executed by the resource using forklift or scanners. Certain tasks you will have them to go to the MFS and they will confirm us back. Okay. So the first attempt would for you when you go for implementation would be to make sure the ABAP push channel is used. The ABAP team has to do those settings and make sure whenever you create a uh, uh, whenever you create this task, it goes to the MFS. So I would just like to show you a telegram, how it looks like, how these MFS some system look like, so that you can get a better idea. So it requires, a lot of configuration, a lot of setup. See this MFS, I would say it's as big as, I would say it is 40 to 50% of what we have covered in EWM. So for that much, if you just talk about MFS, there are so many things in MFS. It is up to 50%. We may spend up around 15 to 20 hours discussing MFS. It's a very it's like an independent module, sub module of EWM. So there are for MFS, learning MFS, there are many technical aspects as well. We probably it is more from a technical guys. They because in a project, we functionals are mostly involved in testing whether the message went, the message came, it confirmed correctly or not, the next task got created or not, whether the resource got assigned to it or not, and then the technical team has to make sure that all the technical configuration, TCP, IP, and all the settings are in place so that this message goes to the MFS system. Okay. So I will just show you some of the technical settings. They are already done in the system. I have given the screenshot of each technical settings. But I would say just understand the process. If at all you go into a project, into an MFS implementation project, then you can go in more detail. Otherwise, just understand high level what it does and what will be expectation from a functional person. So same thing, we have used this warehouse template warehouse WH23 for all the settings, all the enhancements. So we had to do some enhancements in the system for this to work. So with our technical team, we have done that enhancements to just to show you some of the telegrams how they look like in system. So here you can see there is a folder RMFS, and I can show you some of the telegrams how the telegrams look like. I think we might have changed the warehouse. RMFS telegrams. Let me try for this warehouse. Okay. The last one here. Let me remove this. Okay, I think the team has removed the. I mean, there's a bad job to clean, unwanted telegrams or old telegrams. I think the team might have executed that. Just bear with me. Let me try if some of the warehouse, the telegram has been created recently. Okay, yeah. Let's say this warehouse, it has some telegrams. Okay, so these are, and we it has not been cleaned. Generally we run a bad job which will clean all the old telegrams. This for this warehouse we haven't run that transaction. So, so these are all the messages, going to and fro with the PLCs. I'll show you one of the telegram. Okay, so this is a telegram, a message, and you can see a message to you know how idoc looks like, right? But if you see how the message that we send at a telegram level, it's too little. It's like a flat file with certain characters. So what basically the team has to do is, this is EWM system. EWM1 is the EWM system identification. This is the rack identification, and this is the handling unit. This is WTCO is a telegram type. That this is a type of a warehouse. This is a type of a warehouse task confirmation telegram, and there are some more other information here. So this telegram is so this is the message that will be sent to them, just this much. Okay, this message will be sent to the PLC, and in PLC they will map this number of characters to say, okay, this from 21 to 31 it's a handling unit. Okay, and from 41 to 51, it's 41 to 45 it's a task transaction type. So WTCO means a WT is a created, that means a task. This is a request for us, we have to execute the task. So you get, this mapping is required to be done there. So we send a telegram and we explain to the PLC team that this is what is the information. This means, the sending system, this is your recipient system. So anything which is EW1 is the sender. Okay, and this is the PLC. So basically we have something like this. So these are the two PLCs. Okay, the first thing we do is come here and we start the channel, stop the channel. Okay, and here in this telegram, once we start the channel, then we start sending telegrams. So basically what we do is, whenever we get a task which is created in the system which is supposed to be executed via MFS. So let's say this task is supposed to be executed via MFS. So you will see this order. As soon as it is created, it is assigned to a queue which has an indicator that this is the MFS queue, and then you see something like this at your task level, that this is relevant to a subsystem. This is set to X, and the telegram, and whenever it is, system will read the configuration that this queue has to be executed by MFS. System creates a telegram message and tries to send to the MFS system. And this order, will not be, so this order will be sent to them, and this is the telegram message that has been sent to them to that this order is created, move it from this bin to that bin. Okay, so this is the message that has gone to telegram. So it's a WT, that means it's a task I'm sending you, telegram task, and this is for this handling unit, and this handling unit is to take the pallet from the source bin. Okay, and I can also do something like this, simulate telegram. Okay, and I can see all the information, like this is to send the material from here to here, and then this is the resource that will execute the task, and this is the bin from where it will pick the task. Okay, pick the handling unit, this handling unit. Okay, so you can also simulate and create your own telegrams. So telegram, you know, are as functional, we will be mostly you know, um, interested to, do the testing to make sure, the tasks are created, telegrams are sent. If it's not sent, the technical team will help us. And when we receive telegram from them, we should make sure it goes and updates this system and warehouse orders. If you see this warehouse order, you cannot confirm it. It has to be confirmed through telegram only. But if, as an exception, if you want to confirm it, it will give you an error that you cannot confirm it because it has to be done through a subsystem. But still, if you want to confirm it, then you can check this. Okay, I want to go ahead. So you manually check this and then you can confirm. Okay. So this is how a telegram looks like. Uh, this is where, so in this, so what is the benefit that we have? The MFS storage. This is the storage which is automated. Um, zero in this warehouse, it's 0285. Yeah, 0280. This is the MFS storage. So in this MFS storage, these all the bins you can see like you can see in a normal warehouse, but only thing is execution is done by an automated system. So we send the telegram to automated system. Hey, like we for a warehouse order, how we are confirming it on the scanner, same way the same order, we send a telegram and that is confirmed by the sending system. Okay, I mean the automated system. So the benefit that we see is we see all the stock in the monitor. If it was the companies are using a black box, we send the order but we don't see, they do everything and we just see one bin and we see all the stock in that bin. So we don't get a detailed bin wise information. Plus it's an interface, there can be a lot of failures, or there can be a lot of uh, if the interface is down, you will not be able to put away anything. Okay, this is within EWM, so it doesn't impact as much as it would impact in a non-MFS system. And also you get the traceability of all the bins and resources, which, so your MFS, the if you see the resource master, there are some, these are your MFS resource. This is your rack, storage equipment, and this is the MFS queue that it is going to, this is the PLC that it is going to talk to. And similarly, you can create for your conveyors also a separate queue and separate resource that is only used for executing the conveyor movements from one bin to another. Okay, so if you want, you can try this warehouse and do a movement from inbound to the final location. It will create a telegram, and then you can see how a telegram gets generated in the system. Okay, so I just created a task to show you, how a telegram looks like. Um, Again, I would still say this is not used everywhere. So first complete all your process and then you can deep dive more into the MFS things. Yeah. So maybe I would just quickly take you through this configuration. So so this configurations, we did it, but most of them they are done by the technical teams. But you can, if you spend some time and understand the technical things, you should also be able to do it. So basically, our functional settings are, we create a LOSC to tell the system what are the communication points, what are the intermediate points where the pallet will go, and the scanner would read the pallet and then send a message to us. So it doesn't go from where you've kept the pallet to the final, but it may go via some several drop points. First could be your end of conveyor, then other would be um, taking from there to a transfer crane, and then from transfer crane to the final bin. So there can be several intermediate movements. Okay, so we have to do this LOSC, and we have to create a PLC. So you can see you create a PLC, and you can see there are some structures to be created. These are the header structure. This is the structure. This is the format in which we send message to the um, receiving PLC. So you might see in the system we have created a Z structure. So a lot of enhancements were required by creating this Z structure to overcome some of the errors. We have done that. And then you can see for a telegram message, these are some important settings, like what is should be a length of telegram, whether A and R, you send any telegram, and then they send us an acknowledgement. So A stands for acknowledgement. So you can also have acknowledgements of your telegram. Then this is your communication points, whether it's a scanner or it's ID point, clarification point. All the information is can be done at the PLC communication point level. So your queue, whenever we create a queue, we assign a PLC to that. That way system knows that this queue is for MFS. Okay, and then we have several I would say several actions. So when it says WT, we can see a different structure is assigned. We just saw WT right now, yeah. So and you can see different action is assigned. So there's a structure and there's a function module assigned for each action, and each structure for how the message would look like, and each function module is assigned so that when that message comes, what happens in SAP. So we do a lot of structure creation because we want to add our own fields and Z actions. So let's say when the reply comes, confirm the order plus also do these couple of things. So you can write that in our own function module. Okay. Then this is where we do the IP setup of the PLC. So when you do this IP setup, the message goes to this IP, and then we get a confirmation from that IP when that posting is done. So basically for this, I think, yeah, this is the most important settings where we say it's a planned connectivity or a push channel, and then what is the RFC destination we should be sending the message to. Okay, so these are some of the settings that we did for our MFS setup that we did here along with our technical team. So if you want, you can use warehouse W028 or WH23, and you have storage step 0 to 80. Try putting the stock at 0 to 80 and you will see a telegram getting created. If you are more interested, you can just visit this configuration and see how we have done the technical settings to create telegrams in the system. Okay, so as I said, you in your project you would mostly be responsible for testing this, but yeah, if at all you become an expert, and you can also pick up this technical configurations also, like maintenance of IP function modules and the actions for your telegrams. So this was a brief overview for MFS. As I told you, we will not be able to show you the end-to-end process for MFS and labor management because of the dependencies. But I hope you'll get a fair idea from this, and when you go to a project where you have to implement MFS, you know where to start. Okay. So, any questions on MFS?
No, Ron.
Okay, if no questions, then I think we should end the session today. But um, tomorrow, if time permits, we'll complete all the three topics. So, if you have any questions, anything, please please let me know for any other topic. If you have any questions, we can discuss tomorrow. Or else, you can do your practice and you can email me whenever you have questions. So if maybe if we depends how it goes tomorrow. If we complete tomorrow, If we are able to complete these three topics tomorrow, then tomorrow will be our last session. If you have anything, we will discuss at the end of session. Any questions, or if else, you can continue with your practice and you can email me at any point of time.
Sure, Ron. That is a good one. So we can able to get in touch with you.
Yeah, I know most of you are still, at your yard management or at your, I could see some data not after yard, and you guys have still not executed POC and all. So you're lagging with your practice. So don't worry, you can slowly do that. And since the main thing is your basic processes are completed for inbound and outbound, now you take time. Complex processes do take time for execution. So take your own time, try to understand all the connections, and then yeah, I'm available anytime. You can ping me. If at all, we can also have uh, a one-to-one session where I can resolve your queries if you have any.
Sure, Ron. Thank you.
Okay. So any questions before we end for today? Okay. No questions. Then we'll connect again tomorrow and we'll complete our remaining three topics. Okay.
Yes, Ron.
Okay. Okay. See you tomorrow then. Thank you.
Thank
Thank
you,
you,
Ron.
Ron. Bye.
Thank you. Bye.